This is the last tape for this week, and I'm already going to say that I know that the concept that I'm going to be talking about here might give you a little bit of problems. And so, really and truly, what I would like you to do with this tape is just to pause the screen, read what it says, and then come back and listen to what I have to say. This is really important, guys, because a lot of the things that are in here are kind of difficult to understand. This is something that you use in high school and college. And so please, if you'll pause the tape and then come back to me. All right, so basically, this is set builder notation. And I'm not really sure if you used any of this last year, but R stands for real numbers, Z stands for integers, N equals natural or counting numbers. Those are the numbers 1, 2, 3, 4, 5, 6, 7, 8, yada, yada, yada. Also, to let you know that W stands for whole numbers. That's your counting numbers and 0. And then just to let you know that Q stands for rational numbers, kind of like quotient, okay? And so basically what this says is it tells you that you want to tell somebody what the set of the integers is. So example in this case is, I want to say the numbers between 2 and 6, and I just want to say the integers. Now, ladies and gentlemen, I could list these. I could say 2, 3, 4, 5, 6. Okay, that's one way to do it. That's called the list or roster method. Okay, or I could say all the elements of a set that X is between 2 and 6 inclusively and their integers. That would be the rule method. But in this case, with set builder notation, I tell you that the value I choose, that's why I use X, is an element of the integers, okay, such that, that's what this line says. That line stands for such that X is a value between 2 and 6 inclusively. Now, let's take a look at this one. This one says the values I'm looking for are elements of the real numbers, and X is greater than or equal to 0. Now let me think about this. This is probably when I'm talking about a domain, and I want to keep it in the first quadrant, okay? X is greater than or equal to 0. This is telling me, though, that it's a continuous. It goes to infinity and beyond, okay? All right, now I want you to go ahead and stop this and read this. All right, now welcome back. What's important to know is that when you use a parentheses, this means it's not included, okay, or it's open. This means it's included or closed, okay? Now, this is real important when we talk about the concept of infinity. Yep, that's infinity. Or negative infinity. Since you can never reach infinity or negative infinity, it can never be included because it keeps going on and on like the Energizer Bunny, okay? So that always has the open or the parentheses, okay? So hopefully you looked at these rules about open interval, closed interval, half open, non-ending interval to infinity and beyond, non-ending interval to infinity and beyond, and looked at these examples, okay? All right, let's take a look at this one. This gets into a little bit of tricky charted waters, okay? Uncharted waters, not charted waters, when we're talking about things. And when we want to talk about the or situation. So in this case, I want numbers that are less than 13 or greater than 13. I don't want to include 13. So what do? I say that, okay, I go from negative infinity to 13, and then I union that with 13 to positive infinity. Because I use parentheses here and not brackets, take a good look at that, folks. Because I use the parentheses here and not the brackets, that tells me it's not included. Now let's take a look at this. X is less than 0. Oh, that goes to negative infinity, parentheses, 0, parentheses, because it's not included, or 2 is less than x, and x is less than or equal to, oh, that's why I used the bracket there, okay? So, take a look at these words, take a look at the symbols, and let's move on. Okay, so set builder notation. I hope that you take a good look at this. Take a look at the graph, the inequalities, the set builder notation, and the interval notation. Make sure that you write some of these down in your journal and be prepared to ask me questions tomorrow. Oh, Mrs. Rose, my head is swimming. But what does this have to do with functions? Mrs. Rose, I'm so confused. Well, ladies and gentlemen, it's not really about how to confuse you. It's about this. Mrs. Rose draws you a linear function. And I say to you, ladies and gentlemen, what is the domain of this function? Now, if I look at the graph, my x's go to infinity and beyond, and my x's go to positive infinity and beyond. So I could write all real numbers, right? Or I could say my domain stretches from negative infinity to positive infinity. What about my y's? What about my range, ladies and gentlemen? Well, my range goes to infinity and beyond, and infinity and beyond. So for my range, Mrs. Rose could say all real numbers, or she could say from negative infinity to positive infinity, right? Oh, but wait a minute, Mrs. Rose. What if, some of the things that we did in this last unit, what if Mrs. Rose had things stuck in the first quadrant and she had something that looked like this? And let's say that it started right here at 5, and this is f of x equals 1/2 x plus 5. And I said to you, what is the domain? Well, let's see. X is greater than or equal to 0. Oh, Mrs. Rose, why couldn't you have just said it starts at 0 and it goes to infinity? Oh, what about the range, Mrs. Rose? Let's see, where does the range start? The range started at 5 and goes to infinity. Mrs. Rose, I could say y is greater than or equal to 5, or if I write it in interval notation, it starts at 5 and it travels to infinity. All right, I know I've probably made your head swim today, but that's okay. Toodles, have a great night. We're going to talk about this in class tomorrow, unless, of course, you're my 4th period. In that case, we'll talk on Thursday. Have a great green and gold night.